Okay, tomorrow's lesson is all about drawing a picture and writing an equation. And so here's an example problem. It says, okay, let me get rid of that. Rory had some balloons, then gave 35 away. She now has 21 left. How many balloons did she have to begin with? Go ahead and pause it if you need to get that example problem written down. And then we're going to go ahead and make a bar diagram to show the relationship between the quantities or the numbers, okay? And here are the things you need to know about bar diagrams. Envision uses bar diagrams to show how quantities, or the numbers, in word problems are related and what operations could be used. So here we've got 35 and 21 in our problem, and I've got those represented down here. And since these are down here and I don't know the total, I'm guessing I'm going to need to use addition. Something else to keep in mind is that all bar diagrams involve parts and a total. So here are the parts, the total is always on top. What's known and unknown and the relationship between the quantities determines which operation you need to use. For example, since I have these two down here making up the total, which is unknown, I know I'm going to have to add these parts together. So my equation is going to be 35 plus 21 equals x, and the parts 35 balloons and 21, hold on one second. Okay, sorry. So we can add to find out how many balloons she had to begin with. So 35 plus 21, it's going to be 56. That's one way to solve it. The other way to solve is to do, you could set it up as x minus 35 equals 21. Okay, and you're essentially going to have to do the same operation, which is 21 plus 35 to get x equals 56. So Rory had 56 balloons to begin with. Okay, now I'm going to go back to your book to show you some examples of bar diagrams. Problem 1, if you can see that. It says a recipe calls for 3 2/4 cups of orange juice and 1 1/4 cup of lemon juice. How much juice is needed for the recipe? Okay, so the total here well, that's not very clear, is it? This is all on page, there we go. The total amount of juice is unknown, and here are the parts. We know there's 3 2/4 orange juice. We also know there's 1 1/4 lemon juice. So I could add to find the total. Okay, so that's one example. Here's another one. Ethan is building a model plane. He has a strip of wood that is 6 7/8 inches long. He cuts a piece that is 1 3/8 inches long. How long is the remaining piece? Okay, so here we know how long the original wood strip is. We know the part that he cut off, but we don't know the unknown is a part. Okay, so this tells me that I'm going to need to subtract the total length of the wood minus the part that was cut. It's going to leave the unknown part. And this bar diagram just shows you how all the pieces of the word problem are related. Okay? Ziva gave her friends 5 pieces of cake. Each piece of the cake was 1/8 of the whole cake. How much of the cake did she give to her friends? Okay, so we know she gave out 5 pieces, 1 2 3 4 5. We know each piece was 1/8 of the cake, right? So what we don't know is how much of the cake she gave to her friends. So I could do repeated addition, or I could multiply, because all the parts are equal. In the last example, Lynn, Alexis, and Andy are planning to share a used bike that costs $37.50. They are splitting the cost equally. So between Lynn, Alexis, and Andy, that's between 3 people. How much should each person pay? Well, hopefully you can determine that the operation you're going to need to use is division. And you can show that by a total across the top, and the parts are going to be the 3, these are going to represent the 3 people that are sharing, okay? And so this is showing I have my total, and I'm going to have to divide it into 3 equal parts. So $37.50 divided by 3 is your equation that matches this bar diagram, okay? So for your practice tonight, I want you to zoom back out here. For practice, I want you to go to page 45 in your math book and do numbers 1, 2, and 3. So 1 through 3. Okay, so you will need your math book because I didn't want to write out a whole word problem here. Super fuzzy, sorry about that. But for number 1, you do need to draw a picture, which means draw a bar diagram that shows the relationship between each piece of the draw a bar diagram that shows the relationship between each piece of the problem. Okay? So numbers 1, 2, and 3, be ready to discuss those in class tomorrow.